What happens if 0.9 repeating does not equal 1? If we assume 0.9 repeating is not 1, it must be either greater than 1 or less than 1. Since this number is not 1 but 0, it must be less than 1. Thus, 1 minus 0.9 repeating should be some positive value greater than 0. Of course, that value would be very small. Let's call the value x. So what is x? Could x be 0.1? Calculate 1 minus 0.99. The result is 0.01. However, 0.9 repeating is larger than 0.99. So x must be less than 0.01. X can't be 0.1. Could x be 0.0001? Calculate 1 minus 0.99999. It is 0.00001. Since 0.9 repeating is larger than 0.99999, x must be less than 0.00001. X can't be 0.0001 either. Could x be this value with 100 zeros after the decimal point? Calculate 1 minus this number with 102 nines after the decimal point. The result is this number with 101 zeros after the decimal point. 0.9 repeating is also larger than this number, so x can't be this value. None of these values are x. No matter how small the value epsilon for x may be, the situation remains the same. We can always prove that x must be smaller than epsilon. Thus, x cannot equal epsilon. This is because 0.9 repeating has infinitely many nines after the decimal point. If 1 minus 0.9 repeating is the small value epsilon, then 1 minus 0.9 repeating can't be epsilon. This is a contradiction. It's impossible for 1 minus 0.9 repeating to be both epsilon and not epsilon at the same time. Where does this contradiction come from? It originates from the assumption that 0.9 repeating is not 1. Therefore, this assumption must be false. This means 0.9 repeating must equal 1. Do you agree now? Haha.